machine learning, which pertains.
Oh, sorry, Bash. I think Cass requested to record, if that's okay. We can stop recording if you are not
Sure.
comfortable with that.
It's fine. You can
Okay.
record this one.
Okay, sorry.
Okay, fine. So again, a subset of artificial intelligence is called machine learning. Machine learning is just a group of algorithms that can predict or group together data points. So for example, if you have a product and you collect data from your products, for example, transactional data, you can actually use machine learning to segment your customers. For example, you want to group them into gold customers, diamond customers, silver customers, things that we see that some of the industries are already using to tag their customers. A more specialized type of machine learning is called deep learning or neural networks, which borrows mathematics of how our neurons pass information in our bodies. So if you're familiar with the Netflix series Startup, yeah, that's how they use, that's what they are using now. They are using neural networks to identify writing patterns of people. So if you're interested to do something similar, you need to study deep learning, which is a subset of machine learning. Yeah, so now I hope that you can see that the analogy of anatomy to AI is very appropriate because some of the mathematics that we use in artificial intelligence and in data science are borrowed from how we understand the human body. Data science, on the other hand, touches on these concepts and its applications to industry, academic, and social problems. So data science, basically the culmination of these three concepts, AI, ML, and deep learning, but with added tools and domain. For example, if you want to apply artificial intelligence into healthcare, for example, then we call it data science. So application of these three main concepts pertains to data science. Okay. It's also an important aspect of data science that you know communication, okay? Because you are applying very rigorous mathematical equations, for example, or statistical equations into a specific domain. So you need, as a data scientist, to be able to convey what those algorithms mean for the business or for your particular application, okay? So this is very important. This is called data translation. This is important because here in the Philippines, data science is fairly new to most people. Okay. Why is there a sudden boom and clamor to the field of data science? It's mainly due to the three V's of data. So volume, velocity, and variety. In terms of volume, only in the last decade have we produced most of our digital data. This is mainly due to technology being more accessible to people. It means all of us now have computers or even smartphones that can do calculations for us. And we have also better ways of documenting and saving the things we do with it. We now have more powerful databases that can manage huge amount of information. Velocity, on the other hand, is how fast we produce, store, and process this data. There is a theory in computer engineering, so shout out to computer engineers out there, called the Moore's Law. So Moore's Law is the observation that the number of transistors in a dense integrated circuit doubles about every 2 years. So what does it mean? It means that our computers are getting 8 times faster every year. So you can see it in products that we have right now, such as Core i9, and recently Apple released its M1 computers. It's really amazing that now they have integrated GPU inside a very small packet of processor. That's really amazing that we can use and process data in that amount of speed. I can really attest to this point here because I remember when I was doing research in the laboratory back in 2013, my Python simulations and weather predictions took around 3 months to run. Today, when I run the same code, it just takes 3 seconds. And not only can I run it to a local machine that takes up a lot of electricity bill because I will have to leave my computer running for 3 months. Now I can run it in a cloud in a more cost-effective way, saving carbon footprint and so on. The last V of data science is called variety. okay? Which is obvious and can be exemplified by the concept of the Internet of Things. I know in your body right now, you have like connected devices. For example, if you have a smartwatch, you have like Bluetooth devices dangling over your like ears, or this is about connected devices and smartphones that are able to congest as many sensors such as GPS, gyroscope, heart rate sensors. So meaning the type of data that we have right now is not only big, but it also contains more information. It collects more than one single data point from each observable. Okay. We see that these innovations manifest already in many industries. To find the best vaccine, for example, for the components for the vaccines for COVID-19, researchers in Pfizer used artificial intelligence to single out possible chemical compounds. We are even using mathematical algorithms for the best ways that vaccines can be distributed and optimized based on need and priority. But it is not only in the health sector that is infiltrated by the data science bug. Okay? As you can see here in this chart, this shows the percent share of AI or artificial intelligence jobs in different sectors in the United States. Obviously, at the top are information and technology-related companies, but a large portion is in finance, in manufacturing, and the sustainability sector. So it's slowly creeping in, and it's already happening in the United States. So expect something similar will happen in the Philippines in the near future. So exciting. Now, if we look at the trend of new AI startup companies in various industries who have received funding within the past years, more and more varieties added to the mix. Now we have artificial intelligence for fashion, artificial intelligence for analyzing law documents, and of course, AI in e-commerce that is relevant in how we buy during the pandemic. So I see here that in the future curriculum in our universities, artificial in sociology, in law, in physics, in other things that we might not directly associate with artificial intelligence. So that's really exciting. Okay. But this information, the two plots that I shared with you, is not really happening yet in our region. If you want to know what it takes to be a data scientist in the Philippines, we need to know the context that we have here. Now, I am currently teaching data science in a bootcamp company based in the Asian Institute of Management. It's called Esquelabs. We just had our demo day last week, as I mentioned a while ago. Shout out again to my students listening here. It's a good thing that one of the capstone projects analyzed the context of data jobs in the Asia Pacific region, and in particular in the Philippines, Singapore, and Indonesia. So one of the researchers for this project is actually attending this call. Hi, Janina. So what they did is that they scraped job posting websites. The problem that they first encountered is that data from these websites are really dirty. That's normal. When you do like data science jobs, no, lalong-lalo na in the Philippines, no, you will be really like bombarded with lots of data, but you're not sure about its integrity, its quality. It's always like you need to do some transformation with it. Okay, so the problem is the postings that they have scraped don't have a set format. So the students use natural language processing techniques to do topic modeling and entity recognition to find patterns across these countries. Here are some of the results. They saw that to be a data scientist, you need to know mainly Python and SQL, as it is consistently in the top 3 tools that each region or each country look for. Another result that they had is that machine learning is required. It's a required skill, but the nature is different for each country. In the Philippines, for example, machine learning is mainly used for data analytics with business intelligence applications. In Singapore, machine learning is advanced. They use legit or targeted artificial intelligence compared to us, and their systems are focused on big data analytics. Lastly, Indonesia uses machine learning in conjunction and with heavy focus to software development and engineering. So you see that there is indeed a clear distinction of the definition of a data scientist across different countries. Okay. Not surprisingly, academic requirements for data science jobs in these countries vary. So in Singapore, a huge portion of the job postings require either a master's degree or a PhD in what subjects or courses. So here are the subjects that they require, or the courses that will make uh, you to transition to data science jobs easier. So it's IT, computer science, engineering, or natural sciences. So again, if you're currently in these fields, it's easier for you to get a data science job. Okay, but as I mentioned, data science is already starting to trickle into other disciplines as well. So you just need to study it. So in the next few slides, we will define who is a data science person based on the result of the research of our students in SQL Labs. Okay, let's start with the brain. Okay, data science is science by definition, correct? As such, all the things you learned in your science classes in elementary and in high school applies. The brain of a data scientist utilizes the scientific method as a way of inquiry. So it is based on the reproducible methodologies and sound science. Now, what is the language of science? So it's very easy, right? When you do physics before, when you do chemistry before, you use mathematics to solve for those like variables, those observables. Okay. So the language of data science is mathematics. So mathematics is indeed a required skill in data science. I know math is hard, but I also know that it can be learned. Honestly, growing up, I am not good in mathematics, but I made a decision back then to commit. So in high school, I bought myself a book in calculus, like the Bible of calculus, just through like grit and perseverance, answering chapter exercises and doing problem sets. I was able to really enjoy it. So why math? So again, here are my reasons why math is very important in the field of data science and why we use it as a language to communicate our results. So math is precise, math is concise, mathematics is universal. No? So you can use your equations here. For example, the equation of a line, y is equal to mx plus b. It's the same here in the Philippines as with the United States, as with Poland, as with other countries. And mathematics is old but still trendy. Lalo na ngayon, no? Mathematics is a language that computers can understand. So in the advent of big data, in the advent of very fast computers, we can really take leverage of mathematics to optimize our processes and really learn data science, doing evidence-based decisions, and data-driven decisions. Okay. Another branch of science that requires mathematics is statistics. The concepts presented here are all the stats that I use when I do data science projects. So I know you're already familiar with some of these concepts. For example, descriptive statistics is just your simple mean, median, mode, the central tendencies. Inferential, so you can use your hypothesis testing. So differences, you can use your t-test, your z-test. Associative, you can use your correlations. So if like one variable is increasing, you can observe what's happening to another variable. And lastly, you can try and do predictive analytics, so, or using predictive statistics. So for example, you use like regression, linear regression, logistic regression to like say predict future data points based on historical data. So it's not really like too difficult to understand this because I think most of the concepts that we use in data science are already taught in college, are already taught in high school, or even like in elementary for those who are really like advanced. No. Another important field in data science is mathematical modeling, which is the core of machine learning and artificial intelligence. No? So we define a mathematical model as a way for us to represent um, a system that allows for investigation of properties of a system and in some cases prediction of future outcomes. Why is this very relevant? No? Since in data science, you are basically solving problems and the problems are systemic, you might want to represent these systems into a more simplified, more digestible form. So you might want to use mathematics to simplify these systems and with this like variables, you can use operations in math to really like understand it. So it's very important. It's similar to how like the old scientists did it in the past. For example, Newton, Einstein. So for example, Newton, through his experiments, through his observations, identified that the mathematical equation that exists between two masses of planets, for example, is g times mass 1 times mass 2 over r squared. So that's amazing. So similarly, those types of observations can be seen in business, and that I will later exemplify what like applications of mathematical modeling can be like applied in business, can be applied in social good projects, and so on. So why do we need mathematical models? So again, as I've mentioned before, models provide a framework for conceptualizing our ideas about the behavior of particular system. Models also allow us to find structure in complex systems to make it easier for us to digest. Okay, and they are very important in terms of how we make policies to understand the system, to predict the future, and to predict the impact of interventions. No, to find like more relevance to what I am saying, did you know that the MECQ, the ECQ, like programs of the government, they consulted us. So we used like mathematical modeling to give advice to DOH on how we can properly like call on what's the best number of days to call on ECQs. So we use the same mathematical model concepts no, in these types of recommendations to our government that can directly impact the lives of people. And that's really amazing that these equations, they may seem abstract, but in reality, they can be of impact and of value to warm bodies. Mathematical models synthesize results from any experiments. As I've said, we use mathematical models to represent a complex system. So you do, for example, if I want to understand the movement of water, for example, I don't need to get all of the variables of the movement of water. I just need to get, for example, the turbidity, the pH level of the water, so pH, the level or the volume of water. So I'm trying to simplify those things because in mathematics, you need only few variables to really like understand the whole system. So for example, in this image here, although it is fragmented, your mind, the algorithms running in your mind already processes this information. So you see that this fragmented image is actually an elephant. So it's easier for us to infer the whole system without exhausting all of our like mental capacity. No, by just getting the important variables and putting it into equations. Okay. So mathematical models can also unravel the observable. So that's important. In the data industry, we call this pattern recognition. So often the traits that we can measure are not the most informative traits. So sometimes you really need to use mathematics to find patterns in your data that you cannot directly observe in your data set. Okay, we will exemplify that later on. And again, lastly for this point, no, mathematics or mathematical models are powerful tool for us to explore what if scenarios. So for example, what will happen if there is a tidal wave that is like 100 meters in height? So you don't have to wait for that scenario before you know the contingency measures. You can already pre-simulate that using computers. So now you know how to respond given if these scenarios will occur in real life. Okay, so here is one example that I teach in class on mathematical modeling. This equation is called the Lotka-Volterra equation, also called the prey-predator model. So it's the equation that you can see on your left. Okay, it is an equation that can be observed in nature. For example, it models the population of rabbits declining because of an introduction of a prey, of a predator, for example, a fox. So interestingly, this abstract equation can be applied to business problems. So for example, if you want to introduce a new product into the market, you can use this equation to simulate first what will happen to your competitors. Will they die? If I change the mathematical variables like the product release date, the product name, and so on, what will happen to my competitors? How will they react in the market if I introduce my new product? So that's an amazing way on how you can apply these equations into business problems. More relevantly, we also use modeling to understand the pandemic. So back in our previous cohort in our class, the most popular model that we use in simulations for the pandemic is the SIR model. So S for susceptibility, I for infected, and R for recovered. So we use mathematics to see how this population, infected population, susceptible population changes through time. And then we can make proper decisions out of it. And again, it's entirely based on mathematics, and that's really amazing. My problem is these examples might be too advanced, you may think. But to be honest, you don't really need a lot of advanced mathematics for it. Most of the algorithms that I use, even the things that I teach in class, is just arithmetic. One of the hardest equation would be y is equal to mx plus b. So it's just like an equation of a line for linear regression. So well, we also discussed some polynomials, but of course, you don't have to solve it from scratch because you can use computers to solve it for you. Sometimes I encounter exponentials and derivatives, but that's it. I don't go beyond like crazy highfalutin mathematics. So all can be learned. Like even in the confines of the university, I think most of us are required to take at least calculus if you have an engineering or science degree. Okay, so in this slide, we just show that mathematics is just one term in the equation. You also need to learn how to code. You also need to learn domain expertise. So for example, you want to be a data scientist in a bank. You need to know finance terms as well. You need to know the dynamics of the industry. What is the meaning of default? What are overdraft fees? What is clearance date? Okay, again, data science is really a melting pot of skills. It might be daunting right now because I'm saying a lot of things. It's because of our education trained us to be very specialized, but we need to evolve since technology is really growing fast. Okay, a data scientist, since we're all talking about mind or brain, so a data scientist also reads a lot. So books can help. I do read a lot of books. I read a lot of Medium articles, so towards data science, things like that. I also read GitHub code. And as I have said, we need to really keep up to the pace of technology because new algorithms are being published every day. So we need to really be updated of what's going on in the industry. Okay. Just a segue, before I proceed, um, I need to make a point on what's in it for companies to hire data scientists in the Philippines. Okay, what's in it for them? So here are some of the impacts to business that companies might benefit from hiring a data scientist or hiring or composing a data science team. Okay, it can increase their financial bottom line because as we can see, like data scientists really like to optimize processes to remove unnecessary variables in the equation, creating a more streamlined process to save cost. We also would want to the companies would also gain more insights from customers and business operations because of the concept that I mentioned called pattern recognition, right? Because maybe some of the data can be observed by just using a pie chart, a bar graph. You need some more suitable visualization for it, for you to see the pattern for it. And it can also like support day-to-day business decisions. And that's actually one of the purpose of artificial intelligence called automation. So we automate the processes that are boring, we automate the processes that are routine to have more of our time be used to more efficient or like more intense job requiring our brains. So based from my personal experience, here are some of the industries that I have worked here in the Philippines that aggressively take opportunities in data science. So one factor that pushed them to this is the rapid digital transformation due to the pandemic. So they really rushed into polish their data strategies and data governance frameworks to really get a head start because everything is becoming online now. Here are some of the few projects that I do with the company. So inventory management, demand forecasting, so simple prediction algorithms that you already know from your statistics, churn prediction, scheduling and routing optimization problems, ito, Salesforce allocation, so demand supply, promotion analysis, campaign effectivity using statistics, retail planning, and fraud detection, okay, using machine learning algorithms and clustering models. Okay. Yeah. Yeah. Um, let's go back to the anatomy class. Our next part of the body is the muscles. Now, muscles are tools that make our daily functions easier. Muscles, for data scientists, are the tools that we use in operation. These tools are the extensions of our bodies as data scientists. So, for example, if you are someone who works in construction, you use your hands as your tools. But for data scientists, we use software, we use machines to do the job for us. Okay. So this includes our laptops, our RAMs, our processors, our cloud computing resources, and even our coffee. Okay. And at the backbone of these tools are the so-called open source technologies. So if you have some like friends working in development in tech, you can hear some of them speaking about MongoDB, speaking about Python, speaking about R. So these are the softwares that we use for work. The good thing about this is that these softwares are free and is maintained by a community. As a technologist, and as an activist, I believe that technology and tools to access knowledge should be free regardless of gender, race, social status, and so on. By making it free and accessible, we are able to innovate more. That is why you always hear the clamor for open data as well. Because, for example, in the case of our government, if we open our systems to the public, it can be more transparent. So imagine its impact to corruption and so on. Okay. The philosophy behind this is called the four freedoms. So when we use open software, uh, we are free to use it, we are free to modify it, we are free to share the software, and we are free to share these modifications. That's the beauty. You don't have to use proprietary software that you have to pay for in order to develop, in order to code. So that's what is really important here. So I'm going to walk through some of the tools that I use in my line of work. I mainly use Python for programming as my main tool, but I also use R for the visualization. I really like R for statistics. It's really optimized for that, and I love the packages for visualizations in R. Right now, as I am also a data scientist, I need to do a lot of projects related in web app development because in the Philippines, you don't have really a lot of opportunities to apply advanced AI because we're still in our infancy. So most of the project that I do, I develop web apps, I develop APIs. So I use a lot of JavaScript as well in my work. So you might want to screenshot some of the slides here if you want to um, read on the documentations to study for it. For data visualization, I use this things here so you can screenshot it. For mathematics, I mainly use this holy trinity like NumPy, Pandas, and SciPy. So NumPy for the mathematics, Pandas for cleaning the data, SciPy for scientific calculations. For big data, I use mainly Databricks. The students can relate to that. Our students in Escolabs, because we were also teaching them how they can use or do big data using Databricks and so on. For ETL, transform and loading data, we use these kinds of databases and ETL pipelines. For machine learning, I mainly use scikit-learn, but for forecasting, I think FB Prophet is really optimized for doing time series predictions and analysis. Okay. For AI, natural language processing and computer vision, I use these tools. So Spacey, NLTK for natural language processing, Scikit Image, OpenCV for computer vision problems. So for example, if I want to install a camera that can detect if someone is wearing a mask, which I did, you can check it out in my website that I will share later on. I use OpenCV for that project and TensorFlow and Keras as well. For deployment, I mainly use Heroku and Streamlit for a fast way of deploying web apps, so you can try to research on these items as well. For a bit of advanced like algorithms on how you can take leverage of data science, I use network theory or graph theory. Here are some of the packages that I use in my line of work. So you can definitely check out these algorithms. For some of the applications, including robotics, if you're familiar with microprocessors and microcomputers, you can also use Raspberry Pi. It's open hardware, and Raspberry OS is also free. Also Arduino, you can check it out if you would want to try on automation projects. So you can check it out. For environment and the editors that I use for version control, for keeping my code clean, I use Atom. You can also use VS Studio, but I mean use Atom, Jupyter Notebooks for code demonstration. For deployment, I use Spider, and of course GitHub to do my version control. Okay, so I think that's it for the points that I have for the muscles part. One last point that I want to make for the tools is that they are only secondary. So I've mentioned that I discussed the brains first because data scientists are problem solvers first. Python programming software are just mere tools that can be implemented later on. The first thing that you need to know as a data scientist is how you can approach a problem, do systems thinking, design thinking, to properly find ways on how you can optimize your solving process. Okay, the last anatomy to discuss is the heart. Okay, the problem sometimes with technologies is that they are not aware of the repercussions of the technologies that they create. For example, scientists like Einstein, for example, he helped create the atomic bomb for alternative source of energy, but eventually it was used as a weapon of mass destruction. In case of Facebook, for example, Zuckerberg originally created it as a platform to people to connect, but the advent of fake news, disinformation, misinformation, make, make makes us more polarized and fragmented. Data science, again, is a dialectic tool. It can be used as a tool for good, but it can also be used for bad applications. So if you recall the 3 V's of big data, I usually add a fourth V. So it's called veracity. So what I mean by veracity is that you need to ensure as a data scientist that the data that you collect is sourced with integrity. It should be accurate and relevant. We should source it, use it, and process it ethically. And I believe we need to really have more conversations on data ethics. Here is a book recommendation. If you want to know more about machine learning that are used against minorities. One example is prediction of crime. So these algorithms are trained on biased data and causes like reinforcement of racism, among other systemic issues. So other examples include using apps that takes your face, yung mga face app. These apps do not disclose where your face data will be stored or even how it will be processed. Little did you know that your face is used as like training data sets for deepfakes. So that's scary. Um, these facial recognition algorithms as well are trained on certain demographics only. So white males. And in return, these enfranchise other people for using systems. Like for example, this example here of Joy Bellarmini, the algorithm doesn't recognize her face, but when she puts a white mask, the algorithm recognizes the features of the face. So it reinforces the bias that we have already in our systems that we need to really keep in check. So again, my point here is that technology is not neutral. It must take a stand. When the data shows you a problem, it should be in your moral capacity as a data scientist to contribute in resolving it. So in technology terms, in programming terms, when you see a bug, what do? You fix it right away. You don't let it linger because it will definitely cause more damage in the future. In your company, when data is used and processed unethically, it is the responsibility of data scientists to call it out and make moral judgments. As much as tools and extensions of our bodies, data products are also extensions of our humanity. So we need to think it that way that the things that I code for, people will use it, and I should respect how people will interact with the software, with the technology that I use. Okay. Softwares abroad are already starting to vocalize their advocacies. Um, and as they are already able to, again, software abroad are already starting to vocalize their advocacies. And as they are already able to connect technology to politics, they're not afraid to associate other things that they do into politics. They implement a sense of systems thinking and social responsibility. So they are really vocal to the advocacies that they believe in. They really stand up for people of minority, for the advocacies that they believe in. Even the operating systems that you use, if you're familiar with Linux, the operating system, operating system really for preservation and protection of endangered species. So that's really like a subtle way of how you can really convince people to think otherwise of the systemic problems that can be solved using these kinds of systems thinking. Okay, so here is the synthesis and revision of the quotes from your like superheroes. So with great power comes great responsibility. But if you could do good things for other people, you have a moral obligation to do those things. Why am I saying this? Because I am really exposed of how data science is being used in elections in the United States to manipulate people, to like spread campaign and propaganda. And we don't want to let it happen to other people as well. So when you can do the things that you can, no, but don't, and then the bad things happen, they happen because of you. So as data scientists, we really can connect the things because we know systems thinking, we know mathematics, we really know the objective truth of things. So we have the moral ascendancy to really like call out like what's happening in our systems. Um, if you want to kickstart your reflection on how you can do data-related projects, consider visiting the Data Ethics Canvas. So they have there some guidelines of how you can do your data science job with ethics. So check out their canvas. Okay. So my last point here is about the future of work. Um, we are moving towards a learning culture. You can even study the whole data. Even me, I studied data science online. I just enrolled in Coursera. I just enrolled in Udemy. I just learned it by doing projects. No, um, we are becoming more globalized than ever and connected with other countries. So I project that really data science work will be multicultural as well. More and more projects will be available for us to really find jobs abroad and really like do work remotely with a multicultural team. And that's really amazing how many things you can learn from each other's experiences. As such, if you want to learn data science, my advice is, um, okay, sorry. In relation to what I said previously, we really need to adopt in the way we do work. Okay, so for example, if you're having an 8 to 5 job now, you really need to rethink on how you can optimize that. Um, Evidence-based work protocols such as sprints, if you're familiar with agile methodologies, if you know how to segment your work into epics, stories, teams, and initiatives, we see that this culture is becoming more modular. These techniques is all used with like companies such as Apple, Microsoft, those things like that. We need to really learn from their experiences to make our like work opportunities better. We see that the future is becoming more modular again and less rigid. Thus, more opportunities for data science or data scientists are project-based even within companies. The good thing is that data science teams are very versatile. Just give them a problem and they will solve it regardless of the tools. Okay. So if you want to really like learn data science, my advice is project-based learning. Learn it by doing. Join projects, join hackathons. You can join our boot camps. You can also volunteer data work like mapping with OpenStreetMap. You can also practice through collaboration with your friends who are interested. So again, my point here is that right now, if you're feeling lonely in your room, you're alone, don't think it that way. Think of it as an opportunity for you to connect with other people. I think the best way to learn is collective learning. If you learn alone, I know you can do it, but it will take you longer time. But if you learn with other people, it makes the experience better. So you can like practice through collaboration with Kaggle and other platforms, invite friends when you're planning to learn something. I'm also part of a company named Omdena. It is a volunteer platform where you learn artificial intelligence, data science, and machine learning with people around the globe by working social impact problems. We have here some audience who are part of Omdena already. I think they have already like kickstarted their projects. I think today, so I'm really excited for you. The things that we solved here, for example, the last project that I'm with Omdena, I'm one of the lead machine learning engineers, and what we did is we made an algorithm that can detect malaria based on satellite images. So that's really important because, for example, our target area back then is Africa. Malaria is still prevalent in that area, taking lots of lives of people. And by doing these kinds of data science projects, I am making a contribution to really like save lives and use the things that I know for social good, for social development. Okay, so what are the key takeaways for this talk? You really need to understand the whole ecosystem. Um, at the core of data science, again, is scientific thinking, and data scientists are problem solvers first. Tools are just secondary, and lifelong learning is essential. As I said, technology is evolving very fast, so we need to keep up with the pace of how technology is evolving. So if you want to know more about the projects that I do, connect with me through LinkedIn. I have there my website, so you can check the projects that I did previously. Most of the codes that I do, they are open source, so you can like replicate the projects that I'm doing. If you want to make it as a template of your data science learning, please do connect with me. Check out my website. It's free. You can access it for free. So again, thank you so much for having me for this session. I hope you learned something about data science, and I hope that more people will be data scientists in the future because in the Philippines, no, we need people who are capable of governing this country. We need our decisions, not only in the government, not only the businesses, to really apply evidence-based decision-making capabilities, data-driven ways on how we can move on and collectively evolve as a society. So again, thank you so much for having me this afternoon. Thank you. Alex?
That was such an amazing talk. Being a data scientist is genuinely something that I never saw as intersectional. But after speaking to Bash beforehand and listening to your presentation, again, to me, it sounds so interesting as a sociology major. Oops, sorry, give me a second, please. And then your point about tech being neutral, or not neutral, but you obviously have to take a stance on it, was again super interesting because I remember learning about the Cambridge Analytica scandal and how the Philippines was also impacted. It was really interesting to hear you take a stand on that.
Yeah,
So
I have a
thank you.
trivia
That
with
was
regard
really
to
interesting.
Cambridge Analytica. Yeah.
Oh, you do?
Yeah. Facebook, Cambridge Analytica first went to the Philippines during the Duterte election before
Yes.
going to the United States. So
Yes.
yeah, we were data points of how they used algorithms in the US.
Yep, we're the guinea pigs. But yeah, no, that was a really interesting parallel. I really liked seeing that here. But yeah, so thank you. Data scientists are indeed one of the most in-demand jobs in the world right now, and there's no better time to learn how to become one other than today. Thank you for your amazing talk. I genuinely learned so much, and I really hope everyone else did too. Did you know that the third highest click job on Workbean are under data science from employees like Kumu and Brankas? So if you are interested in applying to these jobs, check out these companies on workbean.co and see what it's like to work there. Also, don't forget to catch some of the companies lined up for you this afternoon who might be even hiring data analysts or scientists too. Again, thank you so much, Bash, for taking some time off your busy schedule to talk to our audience here at Workbean. I'm sure the audience has some burning questions that they want to ask, so let's jump straight to it. Let me start by asking these. Are there enough opportunities for data scientists here in the Philippines?
There are a lot. Like there's so much demand in the industries because you know that we are in this age where everything is data driven. Like we have so much data, but we don't have enough skilled people that can analyze and produce insights out of those data. So definitely, even for the companies that I am in right now, they're really actively looking for data science talents in the country. So indeed, in the future, I really see that this will be like a more and more number of positions available to data professionals.
That's so good to hear. Um, and who are your top 3 data science idols? Also, to everyone, please feel free to drop your questions in the chat box below. Yeah, please feel free to drop your questions in the chat box below for Bash to answer anything that you have. But yes, back to the question. Who are your top 3 data science idols, if you have any?
Yeah, that's hard. uh, yeah, there's so many people that we can look up. But it really depends on how you define yourself. Like you need to know yourself first, so you know who to look to. Like for example, one of my idol is Joy Bellarmini. She is the founder of Algorithmic Justice League. So basically, they are fighting Facebook in the US because of algorithmic biases and so on. So if you can search her out in LinkedIn, their work is really amazing. They really like fight for justice in technology in the United States. And I really wanted to replicate the things that they do here in the Asia Pacific. So Joy Bellarmini is one. One of my mentors is actually a physicist because I am from physics as well. So Dr. Reina Reyes, if you're familiar with her, so she's an astrophysicist who proved Einstein right. So we're colleagues. So I get a lot of advice from her on how I can like leverage my skill as a scientist and really like break through my barrier of science and really like go beyond science and do more about like software engineering and so on. And lastly, of course, the default idol would be Andrew Nang. So because I learned a lot from him, I learned a lot of like hours from his courses in Coursera, in Deep AI, in Fast AI. So definitely he's one of my idols.
Okay, great. Could you put her name again in the chat just so everyone has it? And I'll start reading out the questions from the audience. So, how can we break into data science and data engineering?
Sorry, can you repeat?
Yes, of course. How can we break into data science and data engineering?
Break in. So it depends on what your background is because, for example, data science is somewhat different to a data engineer. So the skill sets required for a data engineer is very different. For example, you're focused on like deployment, knowing a lot of like managing data, like doing ETLs, managing databases, and deploying the models from a data scientist. So normally, when we talk about data science, we don't talk to like one single person only. We talk about a team. So a data scientist is always in tandem with a data engineer because the data engineer like cleans the data for the data scientist where the data scientist will analyze it. So after the data scientist analyze the data and do some models, the models will be passed to the data engineer will where the data engineer will deploy it to some APIs or to some any like endpoints or platforms.
Interesting. Okay. The next question is, what inspired you to be a data scientist and how did you start?
Yeah, what inspired me to be a data scientist? When I was a child, I want to be Naruto. I wanted to like have the like Kagebunshin technique, the Rasengan, so things like that. So the closest tech degree that I think is physics because in physics we have plasma. Plasma is ionized gas, the glowing things. So I imagine myself being like a ninja before. But eventually, when I was a child, I really loved the concept like magic, prediction. I do tarot card readings. And right now, in my line of work, I do that. I do predict things using algorithms. I can forecast the future given enough data. So I think I'm living the dream because I am able to. I really don't have a job right now. I have a hobby. Every day that I wake up, I like find inspiration because there's so many things to learn. There's so many things to do. And like to inspire other people as well. When you wake up, like remember the commercial of Nescafe? Para kanino ka gumigising, sabi sa commercial. No, parang tanong nyo lagi na parang ang hirap na nasa mundo tayo ngayon na hindi natin alam yung purpose natin. So, hindi naman masama na wala kang purpose, pero maganda lang na you make most of the things that you can do, not only for yourself, but for service as well to other people. We really need that right now in our country.
Yeah, definitely. And it seems like you found work where you belong. So I'll wrap questions up around 2:15, so you can still answer a couple more. What are the courses, workshops, or books that you would recommend for those who would like to start their data science careers?
Yeah, I think there are many resources, but the problem is you might drown if you like try like online. I want to learn data science. The problem with that kind of thing is that you don't know the correct direction because data science is very broad. You really need to like list it down, define what you want to learn, what do you want to be. The thing that how I did it is medyo makapal mukha ko. What I did when I was studying my data journey, data science career, because after graduating college, I stopped. I did not really like applied for a job. I became a full-time activist. So I was organizing farmers in Mindanao. I was with farmers in Bicol, workers in Laguna for the enclaves. Then after that, I saw that, oh, we need more scientists in the Philippines because we need to like resolve agriculture, optimizing the process, things like that. So I message people that I look up to. So, hey, can I get advice? I want to define myself. I want to like make my skills and talents useful. So I contacted Dr. Reina Reyes. So Reina, can you advise me? Like I wanted to become a data scientist with a purpose. So things like that. So networking with other people will definitely like help. So if you have a time, just message people like in LinkedIn, connect with people, find mentors that can really like guide you throughout like what journey that you plan to do.
Okay, that's a really good point because, yeah, it's obviously a huge endless. Sorry, I'm reading through all the questions now.
Sorry, I think I didn't answer the question. They were asking for like references and books. So for references, yeah, you really need to get a mentor to like define first what you want to like study like later on. But I can give you a head start. Again, learn from projects. But because experience will, according to Marx, experience is our best teacher. So you would know who you are if you try things out. So join projects and learn from that experience, and from those experiences, define your learning path because every learning path is different. It's hard to really like give you a standard code for like everything. Step one, step two. Data science is not like that. You need to know data science that is in context to your current situation.
Absolutely. That's a really good point. And again, you and I spoke about being a sociology major, sorry, and the intersectionality between the two, because I had no idea. So that's a really good point. Okay, so do you know any boot camps that offer free training for those who aspire to be a data scientist?
Boot camps. Yeah, I know in the Philippines there are two main boot camps. The other one I think is free for the woman. You can check it out. They have like scholarships. Also, I work with Esquelabs. We're not entirely free. We have a tuition fee system, but there are many like payment options. You can also like apply for scholarship. For example, we give data for good scholarship. So for example, if you promise to us that you will use data science for social good, we can offer you a scholarship. So yeah, you can check out FTW and Esquelabs as well if you want like free or possible like scholarship opportunities. But again, you can also try Omden. It's free. You can join and learn from legit data scientists overseas. For me, I really learned a lot from people. I think one of my goal in life is to meet as many people as I can and to learn from their experiences. So I learned for example, in the last project that I had with Omdena, we were tackling about malaria. So I thought that I know already some of the things on how I do my methodologies as a data scientist. Was I wrong? I really learned a lot from my fellows in Africa, my fellows in India, and that's really like a great opportunity for me to widen my horizon as well as an individual.
Absolutely, I really like that outtake. It's always very important not to be open-minded and not closed-minded. Okay. What are the limitations in learning data science through online courses, MOOCs, and what are good ways to complement them?
Yeah, the limitations are you don't have a baseline if what you're doing is like correct. Well, that's always the problem of a data scientist. You should always have a baseline. What am I is what I am doing like at par with the standards overseas, at par with the standards in the industry in the Philippines. So that's why you need to get mentors. That's why you need to get more learning opportunities from project-based learning. So I think that that's really how I leverage my career. To be honest, I'm not that old in data science industry in the Philippines. I just started to become a data scientist last year. Yeah, but I already am doing like research before, but the research that I am doing is not really for industry applications. It's mostly for publication and for research. But it become easy for me to apply it because I'm an applied physicist and I'm an activist, so I can really like connect how these tools that I used before in physics into solving problems. For example, I previously worked with PLDT as a data scientist. Their problem is that they have this concept of the knockout load. So people were really like getting a load from other people. So I used physics concepts, for example, the second law of thermodynamics called the entropy, to actually find the patterns who are those who are getting load from other people, because these are not really people, they are computers, so they have like programmatic patterns. So by using physics concepts such as entropy, I was able to capture those like fraudulent transactions.
That was a lot of information to me because I have no idea about this whatsoever, but that's really interesting to hear. Okay, so again, someone asked where to start in learning data science. I can predict something, mostly historical stuff. I really want to do it, but I'm too new in the computer stuff.
Yeah, I think the important step is to start from somewhere. Um, even me, I really like. I'm lazy, to be honest. Like programmers are inherently lazy because they just want to like optimize how they work. They want to automate all the things that are boring. So I'm lazy as a person. Even for my work, I sleep a lot. I only work for around like 4 hours a day maximum. I employ Pomodoro technique. If you're familiar with Pomodoro, it really like optimizes and it suits my working like style. That's why I like it. But if you want to really like kickstart your data science journey, start from somewhere and take it slow. Don't absorb it all at once. So I read a book called, where's that book? Atomic Habits. So the Atomic Habits tells you that you just need to improve at least 1% a day. And by just improving 1% a day, for example, just study, like just read paragraphs or do like coding exercises once a day. That can really like help a lot into like, don't absorb it all at once. Do it incrementally and slowly in your own pace. So you can try Project Euler. So Project Euler is a project where you can try programming problems every day, so you can try new challenges. And it if you know about like advent calendars, if you look at advent code, it's a website. So they have in advent code like in the 12 days of Christmas, so day one, so here's your programming problem, day two, here's your next programming problem, and so on.
Okay, perfect. I don't really have enough time to go through everyone's questions, but Jackie, I hope that answered yours. And the last two that I'll take are, what do you think the Philippines has a problem? What do you think does, sorry, what do you think that does the Philippines, specifically corporations or enterprises, still need to learn about the application of data science?
Yeah, there's a lot. The problem with the Philippines is that we don't have a culture of science. Okay, we don't have Einstein, Newton in our like. We have Bonifacio recently, November 30, Bonifacio Day, and upon my interaction with like C-level executives here in the Philippines, they mostly rely on intuition. So that's the problem. We need to really build trust. But the lesson that I learned, don't overwhelm them because it's hard for them to trust abstract mathematics. You really need to learn how to build trust with these people. And few people can't do it alone. So that's why we need to hire more data scientists to really convince people no, to that data is important, being evidence-based, data-driven is what will transform our future. And we need to start now with you guys. So I hope I have convinced you to become a data scientist because we are in dire need of talents right now in the Philippines.